Welcome to our lesson on the gradient of a line. There are two ways to actually look for the gradient of a line, but in this lesson we shall consider on the formula approach. Okay, we have the graphical approach to find a gradient of a line. It works just as much as the formula approach works. All right, so the formula is stated either this way or that way. It doesn't matter, but in most books you will see the first one. Okay, so this is it. So it is the change in the y divided by the change in the x. So it doesn't matter how you find the change. Okay, but one thing is really important. If you state that y2 minus y1, then you should divide it by x2 minus x1. Also, when you state that y1 minus y2, then the x should be x1 minus x2. So they should correspond. You understand? One here, one there, two here, two there, two here, two there, one here, one there. That is how they should be. Right, so these are the two options that you can state your formula. Okay, so let's start with the first question. Find the gradient of the line joining these points. Okay, so we have our 2 points here. Now let the first point take the x1, y1, all right, and then the second point we take x2, y2, all right. So now let's find the gradient. We would take, let's use this formula, all right. Since most of you will come across this one, let me just introduce it to you and then use it in the solutions as well. All right, so y2 is the 4. Okay, so y2 here minus y1, which is the 3, over x2, which is 6, minus x1, which is 5. All right, so 4 minus 3 is 1, then 6 minus 5 is also 1. Right, so 1 over 1 is 1. Second example. So we are going to find the gradient of the line joining these points. But now be careful. There are some numbers which are negative. All right, so y2 minus y1, all right, so we have negative 5 minus 4. Then we have x2, which is 6, minus x1, but x1 is negative 2, so you see minus minus, all right, so this will give us negative 9, but 6 minus minus 2 will become plus. Okay, so we have 8. So our answer, or the gradient, is negative 9 over 8. Let's consider example 3. This is a bit different. So let's see. The line joining 2,1 to 7a has a gradient of 1. Okay, there's supposed to be a gradient here. Has a gradient of 1. Find the value of a. Okay, right. So we know that gradient is given as the y2 minus the y1. Okay, so we have a minus 1 over x2, which is 7, minus 2. All right, okay, but the gradient is what? Is 1. So we equate this whole thing to 1. Now we want to find the value of a, so all that we will have to do is to solve for a. Okay, so a minus 1, then we have 7 minus 2. That will give us 5. Okay, so this is what we have. This is where the 5 is coming from. All right, so this is where we ended on the previous page. So let's continue. So we cross multiply, you may say that, and then we solve for a. It will give us 6. Okay, all right. The next example. We have a line joining these 2 points and has a gradient of half. The previous question we had a gradient of 1. This one has a gradient of half. Our job is to find the value of D, the value of D. So let's find it. Now gradient is D, which is minus what? 6, because it's y2 minus y1, okay? Then x2, which is 7, minus x1, 3. So this is what we have. We shall equate it to what? To half. But 7 minus 3 will give us 4. Okay, so this is what we have. I'll repeat this on the next slide. Okay, so we have this. Now we solve for D. So let's cross multiply, okay? So 4 times 1 and then 2 times this, all right? So this is what we have. Then we expand this bracket. We expand this bracket. So when we expand, we will get 2D minus 12, all right? Then we will add 12 to both sides. So we add 12 to both sides so that this part will be 0, all right? So we have 16 is equal to 2D. Then we strike each part by what? 2. We divide through by 2. So D is 8.